Okay, several people are riding in a hot air balloon, and the combined mass of the people in the hot air balloon is 310 kilograms. The balloon is motionless because of the downward acting weight. Of the people in the balloon is balanced by an upward acting buoyant force. So explaining what that is kind of tricky, but just know that there's an upward force so that the forces are balanced. I'm going to call that force buoyant, and I should call this FW. Okay. So it's kind of two problems. The first one is the forces are balanced, which lets you determine the buoyant force. And that's how ships stay afloat, is there's an upward force on them equal to the volume of the water, or in this case, the air that they displace. So in situation one, the forces are balanced. And so we're going to say the sum of the forces equals 0. So the buoyant force is up and the weight is down, and they are balanced. So the buoyant force equals the weight, and the weight is equal to mg. So 310 kilograms times 9.8 meters per second squared equals 3,038 newtons. Okay. And then in part 2, I don't know if you've seen in some of the movies, they have like these sandbags hanging off the end of the hot air balloon, and they throw them overboard. So we're going to drop some certain amount of mass overboard so that the balloon starts to accelerate upward at 0.15 meters per second squared. Okay, so if it's accelerating upwards, the buoyant force must be bigger than the weight. And the buoyant force isn't changing because that's determined by the volume of the balloon, right? So we're not changing the volume of the balloon. You don't know, again, we haven't talked about buoyant force, but the buoyant force is the same, which means the weight has to be less because we threw stuff overboard. Okay, so now instead of the forces being balanced, the forces are unbalanced. Up is still positive, down is negative. So the buoyant force minus the weight equals m, which we don't know. That's what's tricky. It's not 310 anymore, times a, which we do know. And the buoyant force is 3038 minus, we don't know what m is, but whatever it is, the weight is going to be m times 9.8 equals m times 0.15. Okay, now we're solving for m, so we have to combine like terms. So 3038, and we're going to add mg to both sides, equals mg plus m times 0.15. And then we're going to factor out the m, and I'm going to turn g into 9.8. So, oh, you know what? I didn't do that out individually. Sorry, 9.8 plus 0.15 m times 9.95, and let me see if this will let me scroll upward. Awesome. So m equals 3038 divided by 9.95, which is 305 kilograms. That's not quite the answer because the question is, how much mass do I throw overboard? So I used to have 310 kilograms. I want 305 kilograms. It's not that much because you can see the acceleration is pretty small. And so the difference is chuck 5 kilograms overboard. Okay, so this one was tricky because you had to understand that there was this thing called the buoyant force and that isn't going to change when you throw things overboard. But hopefully the basic principle of up minus down equals MA is making sense.